Today we're going to talk about writing polynomial functions, irrational and imaginary roots. We learned to find irrational solutions to quadratic equations in Math 2. For example, by the quadratic formula, solutions of x squared minus 4x minus 1 equals 0 are 2 plus root 5 and 2 minus root 5. Remember that conjugates, the number pairs of the form a plus root b and a minus root b. Complex conjugates, where we have the I, so a plus bi and a minus bi, where a is the real number and bi is the imaginary portion. So the irrational root theorem states that if a plus the square root of b is a root of the polynomial, then a minus the square root of b is also a root. And the imaginary root theorem states, of course, then if a plus bi is a root, then a minus bi is also a root. So for the first example, it says a polynomial with integer coefficients has 1 plus root 3 and negative root 11. Find two additional roots. So that means that, of course, 1 minus root 3 is a 0. And remember that the way that we write this would actually be 0 minus root 11. So that means 0 plus root 11 is the other root. So positive root 11. Polynomial with integer coefficients has roots 2 minus root 7 and root 5. So the conjugate of that would be 2 plus root 7. And remember, this one is 0 plus root 5. So then negative root 5 or 0 minus root 5 would be the conjugate. If we have 3 minus I and 2I, the additional roots would be 3 plus I. And if this is 0 plus 2I, the other root would be 0 minus 2I or negative 2I. And for this one down here, we would have negative 2 plus 9i. And then if this is 7i, negative 7i would be the conjugate, because again, it's 0 plus 7i, so 0 minus 7i. So the next part, we're going to write the polynomials functions in standard form given the zeros. So step 1, rewrite the zeros as factors, multiply, and then put them in standard form. And we've already done some of this before, so if I want to write this in factored form, remember it's always x minus the 0, so x minus 3, x minus 5, and x minus negative 1 is x plus 1. And you could always check your work by setting equal to 0 each factor and then making sure you get 3, 5, and negative 1. So if I want to put this in standard form to write the polynomial, that means I need to FOIL this out. So I'll go ahead and FOIL these terms first. So we have x minus 3 in front, and that is x squared plus x minus 5x minus 5, and then we're going to combine like terms, so x minus 3 times x squared minus 4x minus 5 when we combine our like terms. And then, of course, we need to FOIL again, so this x times these three terms and negative 3 times these three terms. So that gives us x cubed minus 4x squared minus 5x minus 3x squared minus 12x plus 15. And then we just need to combine like terms. So f of x is equal to x cubed. Here we have the like terms, so minus 7x squared. And then here and here are like terms, so I think that should have been plus 12 minus is plus, sorry. So here and here, that would give us plus 7x and then plus 15. So this would be our polynomial equation. So over here, go ahead and do number 2 on your own. When you're done, you can unpause the video and check your work. So here we have x minus 0, and then x minus 3 halves, and x minus 2. Of course, we don't want to leave it as a fraction, so we're going to rewrite this, and x minus 0 we don't need to write. So this would be 2x minus 3 and x minus 2. And then let's go ahead and FOIL this out. So x times 2x squared, and then that would be minus 4x minus 3x plus 6. So x times 2x squared minus 7x plus 6, and then distribute that x to each of these terms. And so f of x is equal to 2x cubed minus 7x squared plus 6x. Looking at the next one, remember that imaginary and irrational numbers come in complex conjugate pairs. So if you have 4i as a root, that means that you also need negative 4i as a root as well. Negative 7 is not imaginary number, nor is it irrational. That's why we are not writing the conjugate pair. So for this would be x plus 7. And this root right here would be x minus 4i, and this root right here would be x plus 4i. Always multiply conjugate pairs first when you're doing these problems, because they should get rid of the I or the square root. Um, it will get rid of I and, or I guess I should say, or the square root, depending on if you have an imaginary or irrational number. So if we multiply the conjugates first here, I'm going to multiply that out. So we have x plus 7. So when I FOIL this out, I get x times x, which is x squared, and then plus 4xi, and then minus 4xi, and then we get minus 4 times 4 is 16, and then I times I is I squared. And so for this, notice that these middle terms cancel out. Recall we learned in Math 2 that I squared is really equal to negative 1. So we have negative 16 times negative 1, which is actually equal to 16. So we have x plus 7 times x squared plus 16. So notice the i's all canceled out, which should always happen when you multiply your conjugate pairs together, because when you're writing your polynomial equation, you're writing with real integer coefficients. And so if you have an I left in your equation after multiplying the conjugates, make sure you look at your problem again. And then, so now we need to, again, FOIL this out. So we have x times x squared, which is x cubed, plus 16x plus 7x squared, plus 112. And then we just need to write this in standard form. So f of x is equal to x cubed plus 7x squared plus 16x plus 112. Looking at the next one, it looks like I accidentally wrote that 4 twice. Sorry, that's just number 4. And so one of the zeros is 4. And then we have 5 plus root 6. So this would be the 0 or root that needs the conjugate pair answer. So 5 minus root 6 is also an answer, because remember this is irrational. So irrational roots and imaginary come as a conjugate pair. So that means we are going to multiply the conjugates out first. So first I need to write the factors. So x minus 4, and then this is going to be x minus 5 plus root 6, and x minus 5 minus root 6. And then I would distribute the negative to both these terms. So this would be x minus 4 and x minus 5 minus the square root of 6, and x minus 5, and minus minus becomes plus the square root of 6. So of course we want to multiply out the conjugate pairs first. So if you have a hard time foiling this out with the 3 terms, remember you can always make a box to help you. That's perfectly okay to do. If I make a box, we have x minus 5 minus root 6 and x minus 5 plus the square root of 6. So x times x is x squared. So it gives me minus 5x. X times negative 6 is negative x root 6, because this does not have a radical, so it stays in front of the radical. It doesn't go underneath. You don't multiply it with that unless it has a radical. So this would be minus 5x. Negative 5 times negative 5 is 25. And negative 5 times negative 1 root 6 would be positive 5 root 6. Again, this is not underneath a radical, so it stays in front. And then we have x root 6. This would become negative 5 root 6, and root 6 times negative root 6 would be negative root 36, which of course is equal to negative 6. The negative stays because it's on the outside of the radical. And then we can go ahead and combine our like terms. So for this we have x squared, and then we have the negative 5x and the um, negative 5x. And then here we have the root x root 6 and negative x root 6. Those are opposites, so they cancel out. Negative 5 root 6 and positive 5 root 6 also cancel out. And then the other like terms we have are the 25 and the minus the 6. So when we do that, that gives us x squared, negative 5x, and negative 5x is minus 10x, and 25 minus 6 is plus 19. So that's equal to the, these being FOILed. So if it helps you to do the box method to FOIL it out, that's fine, or if you don't need to, that's perfectly okay too. And then of course we're going to multiply this again, so you could do the box method again, or again you're just taking the x times all three of these, and then the negative 4 times all three of these. So when we do that, we hit x cubed minus 10x squared plus 19x minus 4x squared plus 40x minus 76. And then when we combine our like terms, x cubed, and then we have minus 14 x squared, and then here we have the x's, so plus 59x minus 76. And that looks like it's it. So you just have to remember that not always are they going to give you the conjugate pairs for each of the problems. You just have to remember that, as we said before, irrational and imaginary answers come in conjugate pairs. And that's it.